Alrighty, the goal of the next few minutes here is just to enlighten you on really the size of the universe. And in order to appreciate that, you kind of have to maybe use scientific notation a little bit, which we've done. We've talked about how, of course, the sun is 93 million miles away. It would take us 1 million years to get there, traveling at 80 miles an hour, but it would only take you 8 minutes if you were traveling at the speed of light. Okay, and so that brought about a whole idea of the light year. How far could you get in 1 year if you were traveling at the speed of light? And we determined that that was about 5.8 trillion miles. And so when people start talking about distances in space, they don't say, "Oh, it's 2 days away," or 12 million thousand miles away. They talk about how many light years away it is. Okay, assuming we assume that you travel at the speed of light as you go from one place to another in space, and that's because the universe is so big. So the light year is at least 5.8 trillion miles. And so we're going to look at a small map of just a part of our universe, in fact, just a part of our Milky Way galaxy. Okay, we've already addressed the fact that we are 8 minutes or 93 million miles away from the sun. Okay, and in this picture, the sun is right there, which means that we are probably right there. Okay, right beside it, and probably even closer. And we know that because this is our solar system right here. Okay, we've also got Pluto and Mars and everything all in our solar system here in this map. But look up here. This is the thing that we're going to be looking at through each example here, and that is that the distance from here to here is 10 light years. Okay, so from the sun in this map to what's called I guess a star like 61 Syzygy, that's almost 10 light years away. So if you were to go from the sun to Syzygy, traveling at the speed of light, it would take you 10 years. Okay, this is 10 light years apart, and so I just want you to really appreciate this for a second. Okay, I want you to hold a stone in your hand. Just imagine you're holding a stone in your hand. Okay, touch the stone. Okay, you got the stone? Throw the stone at 670 million miles per hour. That's the speed of light. Okay, and throw it at the Cygni star over here. Okay, if you threw it at the speed of light at 670 million miles per hour, it would take 10 years to get there, to that star. Okay, so that's a very large distance there. Okay, that's not a Sunday afternoon drive. Okay, what we're going to do now is actually we're going to take another step back, more further away from the sun. Okay, because now you notice that the distance from here to here is now 100 light years. And so on the map, if you were to start this arrow, again, there's our sun in the middle of the map. Don't be confused, that doesn't mean it's in the middle of the universe. Okay, but then maybe take this line and direct it towards say that point right there. It would take you traveling at the speed of light, 670 million miles per hour. It would take you 100 years to get to this point in this map. If you threw that stone off the surface of the earth right now at the speed of light, it would take 100 years to get to this point in the universe. We can take another step back. Okay, again, there is the sun still pretty much in the center of our map right here. Okay, you're starting to see these clouds forming. These are part of our Milky Way galaxy that will become more obvious in just a second. Okay, But again, notice now that on the map, the distance from here to here, our line here is representing 100,000 light years. So if you were to go from the Sun to the Orion Nebula cluster or galaxy or whatever it may be there, you'd have to take 1,000 years traveling, not at 80 miles per hour, but at 670 million miles per hour. And that's just going from here to here. Okay. Some of you may notice this next picture we're about to see. This is our Milky Way galaxy. Okay. Notice now we're no longer in the center of the map. Okay. We are somewhere over here in this arm. Okay. You don't want to be in the middle of this galaxy. Actually, it's very bad there, and so we're in a safe place here. But to get to the center of our galaxy, if you're paying attention to our scale, that's the distance from here to here is 10,000 light years, and that's about the same distance that it is from our arm of the Milky Way galaxy to the middle of our Milky Way, to the middle of the Milky Way galaxy. Okay, it can take you 10,000 years just to get to the middle. Okay, so you're starting to hopefully appreciate the size of our Milky Way galaxy that we are a part of. However, you need to understand that there are many more and more galaxies in our universe. Okay, you can see here some other dwarf clouds and galaxies all around. Here's our Milky Way galaxy in this map in the middle. And if you would travel at the speed of light for 100,000 years, you could get from our Milky Way galaxy to, I don't know, the Ursa Major galaxy perhaps, okay? And see, what might be other solar systems, suns, Earths. And of course, that's where people start talking about maybe there's got to be someone else out there living on an Earth like ours, which I'll let you figure that out for yourself someday. Going to take another step back. Now we're talking about 1 million light years. Okay, that's the length of this line now represents you traveling at 670 million miles per hour for 1 million years. That's a lot of generations of people. Here's our Milky Way galaxy here in the center, and it would take, almost, it looks like about what would be 2 million light years to get to the Andromeda galaxy. So you'd have to take 2 million years traveling at the speed of light to get to another big galaxy in our universe. Okay. And we can continue going here, taking a step back. I no longer know where our solar system is. I think, I would guess that it is in this group here. I remember seeing the Ursa Major cluster or galaxy somewhere. And of course, if we just take this distance here, being to 10 million light years, that could get us to the Canes groups, I guess. It might even be 20 million light years. Or, of course, if you extended this line enough times, you get to the Fornax cluster of galaxies. Remember, our galaxy is thousands of light years wide. And we're talking about a group of galaxies that big, 10 million light years away. Okay, so things get very large here in the universe as you continue taking another step back. Here are some more galaxies that we've seen in telescopes that have explored beyond what we could see, of course, with our eyes. I don't know where we are anymore, but I think it's worth noting that this is now just 100 million light years, that distance. Okay, and so just to get from one supercluster to another supercluster over here, it would take you over 100 million years traveling at the speed of light to get there. And this is just one more step back of what they call the known universe, okay, a map. And I guess we may be in the middle of this only because that's the equidistant apart from everywhere else that we may have explored. But of course, the serious factor here is that that's 1 billion light years right here. Okay, so if you would stretch this all the way across, it would be about 14 billion light years to get from one side of what we know to be the universe to the other. It's not saying there's nothing beyond that, but of what we know, traveling, if you threw that stone at 670 million miles per hour and you start on this side, it would take 14 billion years to get to the other side of the universe, and it would probably take you longer as the universe continues to grow as we know it. Of course, there's so much there that we need to consider that makes this just a really significant statement. So that's a map of our universe, folks. I do have one other fact that you might find interesting. If you look at the number of stars in the visible universe, they've counted 30 billion trillion. And although I could write that out with a lot of zeros, it's much easier to represent that in scientific notation, which would look like that. Okay. And again, appreciate when you look up at the sky at night, you are seeing the light from stars that are millions of light years away. So that means that their light took millions of years to even get to where we could see it. And so think about the fact that you may be seeing the light of stars still coming into our night sky, but those stars may have already burnt out. Their light is just still coming our way years later. And of course, there are stars burning in the universe that we have not seen because their light has not had enough time to make it to Earth yet.